Okay, we're starting on the 4.2 study guide, and this study guide pertains to a particular shape, parallelograms. We're going to be talking about the definitions of parallelograms, the properties of parallelograms, and then talking about how we prove or how certain things show us why those properties and definitions are true. So here we go. In 10 words or fewer, define parallelogram. So a parallelogram, again, we know a lot of things possibly about parallelograms, but the true definition is just any four-sided shape that has two pairs of parallel sides, or opposite parallel sides. So take a second to write down this definition, and then let's actually sketch one out. So remember that we want two sets of parallel sides. How are they going to signal to us that they are parallel? We remember we use these little marks that mean parallel. So like two arrows or one arrow. So because this is a four-sided shape that has two sets of parallel sides, we can say that it is a parallelogram. So take a second to draw that little image as well with your definition. Feel free to pause the video if I go too fast and you still need to write some of this. Okay, so here we go where a shape is now given to us, and we're saying that the name of this parallelogram over here is parallelogram WXYZ. So just like we named triangles from previous chapters, we're going to call this parallelogram by its four-letter name. And instead of a little triangle shape, we draw a little quadrilateral shape. So we're going to say WXYZ is the name of this quadrilateral. And then what are the parallel sides of this quadrilateral? We're going to say that WZ, see that bottom side there? Side length WZ is parallel to side length XY. Notice that I went left to right on the bottom side, so I went left to right on the top side. And then what else do we know about this image? We know that side length WX is parallel to side length ZY. So I wanted you to get familiar with all these little notations that we're going to use. Remember this symbol that means parallel. And remember that this little tiny quadrilateral for quadrilateral WXYZ is our parallelogram. Okay, so draw that image, draw out those three things we can for the notations for that image. Now let's talk about this property. So we've got the definition, two opposite parallel sides, but now we're going to talk about the properties of a parallelogram. One of the properties of a parallelogram is that the opposite sides of the parallelogram are congruent. Meaning that they have equal length. So you guys probably already knew that. You probably knew the sides were equal, but that's not actually part of the definition, because if a quadrilateral has opposite sides that are congruent, could be a square, could be a rectangle, could be a parallelogram, could be a rhombus. There's lots of different quadrilaterals that have equal side lengths. So what makes a parallelogram is its definition. They have to be parallel. Okay, that's one of the properties that we know is true. So if ABCD is a parallelogram, follow these steps to find the lengths using this property. So do you see how they gave us some information here with this image? They gave us 16 plus 2x and 10 plus 8x, both of those expressions. And they also gave us 12 and 12 on the sides there. So start with the length of BC and AD. Let's look at those equations or expressions. BC is equal to 16 plus 2x. Do you guys see that labeled up top? And AD is equal to 10 plus 8x. And then we know that BC is equal to AD because parallelograms have equal opposite sides. So if BC is equal to AD, can't we set those equations equal to each other? So 16 plus 2x is equal to 10 plus 8x, and then we solve. Let's first subtract 2x from both sides. And notice we get 6 x's on the right, and these ones cross out. And then they minus 10 from the left from both sides. And notice that 16 minus 10 gave us this 6 right here. If that two-step equation was confusing for you, we can usually break that out a little bit more and not do 2 steps in one, but so hopefully you followed both those steps. Finally, we'd be dividing both of these sides by 6 here. And when you divide both sides by 6, do you see that x is actually going to equal 1? So all that work was to find the value of x, but now they asked us for the length of BC and the length of AD, so we have to go plug that x value in. 16 plus 2 times 1, 16 plus 2 is just 18. And finally, plug in a 1 into the other one. 10 plus 8 times 1, or 10 plus 8, which is just 18. Well, these better equal each other when you're done, because that's the whole point, right? These are supposed to be equal segments. So we just used equations to solve for those 2 missing side lengths. How'd you do? Again, pause the video if you need time to finish that. All right, what's another property of parallelograms that you probably already know intuitively is that the opposite angles of a parallelogram are also congruent. Okay, let's see what I mean. If this angle is an 82, then what's this angle over here? Also an 82 degrees. And if this guy down here is a 98, then what is this guy over here? Also a 98. And that's it. Parallelograms have the property that opposite angles are congruent. Take a minute to write down that property up here and draw that little image. Again, pause the video if you need more time. Okay, let's use this property to solve just like we did on the steps of the previous one. So now we know opposite angles are congruent. So notice here that they gave us an expression of 107 plus 10x, and over here it's 97 plus 15x. So we're going to use these expressions as well to solve for x and then to get those angle measures in the end. So measure of angle A is 107 plus 10x. Do you see that label? Measure of angle C is 97 plus 15x. Since we know that opposite angles are congruent, can't I set those two expressions equal to each other? 107 plus 10x is equal to 97 plus 15x. We're going to start by subtracting 10x to both sides. Notice that 15 minus 10x gave us this 5x. And then in the same step, they're minusing the 97 from both sides. Again, they did both of these steps in one, and this could be confusing to some of you. I hope you can follow along. And then we divided both sides by 5. Do you see that x is going to equal 2? 5 times something equals 10. Now that we have that too, we're going to take it and plug it into each expression in order to solve backwards for the angle measure. So 107 plus 10 times 2 is 107 plus 20, or 127 degrees. You okay with that one? 97 plus 15 times 2, or 97 plus 30, is 107 degrees. Sorry, I think I said 107. I meant 127. Okay, now these should be equal because that's the whole point, that these two opposite angles in a parallelogram are congruent. So we should get the same answer for those if we've done it right. Again, pause the video if you need more time on that. Okay, let's see this next property of parallelograms. It says that consecutive angles of a parallelogram are supplementary. Now this word keeps coming up, and I realized I'm assuming you know what consecutive means. So let's take a second to just write out consecutive. Consecutive means right after or the next thing. So, or right next to. So if I've got a parallelogram, the consecutive angles would be like angle A and B, the angles right next to each other. So these two angles are not equal. These angles across are equal. So what does that mean about the consecutive angles, A and B? It means that they are supplementary. Consecutive angles of a parallelogram are supplementary. What the heck does that mean again from Unit 2? It means I could add those guys up to 180. So I know that angle A, equals the other angle A, the opposite angles. And I know that angle B equals angle B, the opposite angles. So now I'm learning about A and B together. Those two are supplementary. This is our next property. So let's go solve using this property. Notice that the measure of A is 30 plus 5x. See it labeled up there? And the measure of D is 15 plus 10x. And because I know this property, that the two of these things combined are supplementary, they add up to 180. So let's go plug in these expressions. 30 plus 5x plus 15 plus 10x all adds up to 180. And now we're going to combine like terms and solve. Do you see how your algebraic or equation skills are coming in with the geometry here? That's the true goal of an integrated curriculum. You're doing geometry using your algebra skills. So here I go combining like terms. Do you see that 30 and 15 are a constant and they add up here to 45? And do you also see that 5x and 10x are a total of 15x's? And then we minus this 45 from both sides, squeeze that in there. And that leaves us 15x on the left and 135 on the right. So take a minute to divide with your calculators. Divide both sides by 15 and tell me what you get. You got it. Did you get a 9? Now that we got the 9, we can take that x equals 9 and plug it in to find the full measure of both of the different angles. Remember that these two answers are not going to come out equal, that these two answers are going to come out to two different numbers that add up to 180, because this is the property about being supplementary. So 5 times 9 is 45. 45 plus 30, do you see how this one gives you 75 degrees? And then 15 plus 90 is 105 degrees. Do you see how the 105 and the 75 add up to 180? Check that they are supplementary. And they are. Again, pause the video if you need more time here to finish writing that guy down. All right, next property of the parallelograms. This has to do with the diagonals, and we just talked about diagonals for the first time today in our notes. So diagonals of the parallelogram bisect each other. Again, a lot of these things I'm thinking you might already know about parallelograms. So let's envision this one real quick. What is a diagram? What is a diagonal? Remember, the diagonal goes from vertice to vertice across. And the definition of, or the property of the diagonals of a parallelogram, these bisect each other. That means now that this segment equals this segment and this segment equals this segment. They bisect each other. We're going to go use this concept here to solve. So BM equals this expression, this little segment here, and DM equals this thing. And we know that BM and DM are equal. These two are, since those are bisected, we know that those two things are going to be able to be set equal. Now I'm going to use a different color. AM is equal to this expression, and CM is equal to this expression. And we know we're going to be able to set those equal to each other. Okay. So BM is equal to 22 minus 3x. DM is equal to 10 plus 9x. And we know that these two are equal. So go ahead and write those expressions as equal. We're then going to add 3x to both sides. See how they got this 12x right here? And then they minus the 10 to both sides in the same step. See how we got 12. Take a minute to divide both sides by 12. We're noticing that yet again, x equals 1. Now that we got a value for x, we plug it in. 22 minus 3 is just 19. And then 2 times BM, whatever we just got, is 19. So BD equals 38. Repeat steps 1 through 5 to find AC. So these same steps up here to find AC, we're now going to use the yellow ones. We're going to write 7y plus 13 is equal to 2y plus 38. And then we're going to subtract 2 y's from both sides. And then we minus the 13. And I'm getting that y is equal to 5. Remember that that's just the value of y. We now need to plug in to the 7y plus 13. And that we get that AC, we're finding that was just AM. That's just one of the little sides. And we know that AC is equal to 2, both parts of that. So 2 times 48 is equal to 96. The whole length is 96. So feel free to pause the video here if you're still writing, you still need time. So just to reiterate, we just found the whole length by first finding one of these, and then we doubled it to get the whole length. Does that make sense? Okay, finally, this last little part, the definition, we just learned is that opposite sides are parallel. That's the definition, has to happen for a parallelogram. And then we talked about the 4 properties. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. Remember, A plus B equaled 180. And diagonals bisect each other. Pause the video right here on this screen so you can write down that definition, write down those 4 properties, and draw an image of each for yourself. And that's the end of our study guide. How'd you do? How much of this was stuff that you remembered?